Conformations. What are conformations? In alkanes, free rotation about carbon-carbon single bond is possible. This rotation results in different spatial arrangements of atoms in space which can change into one another. Such spatial arrangement of atoms which can be converted into one another by rotation around a carbon-carbon single bond are called conformations. Infinite number of conformations are possible. Rotation around a carbon-carbon single bond is hindered by a small energy barrier due to weak repulsive interactions between the adjacent bonds. Such repulsive interaction is called torsional strain. Next we shall learn about conformations of ethane. Ethane is CH3 single bond CH3. So we can consider the carbon-carbon single bond. Keep one carbon atom stationary and rotate the other carbon atom around the CC axis. There are two extreme cases. One in which hydrogen atoms attached to two carbon atoms are as close together as possible. This conformation is known as the eclipsed conformation. Other in which hydrogen atoms are as far apart as possible will give us the staggered conformation. Intermediate conformations are known as skew conformations. Sawhorse and Newman projections. Consider Sawhorse projection given in the figure. Eclipsed and the staggered conformations are shown. In Sawhorse projection, carbon-carbon bond, the single bond, is shown by a longer straight line. Upper end of the line is slightly tilted to the right or to the left. Front carbon atom is shown at the lower end of the line. The rear carbon is shown at the upper end. Each carbon has 3 lines attached to it corresponding to 3 hydrogen atoms. The lines are inclined at an angle of 120 degrees. Now consider Newman projections. You can see the figure given. In Newman projection, the molecule is viewed at the CC bond head-on. Carbon atom nearer to I is represented by a point. 3 hydrogen atoms are attached to the front carbon, and these 3 hydrogen atoms are shown by 3 lines drawn at 120 degrees. The rear carbon atom away from I is represented by a circle, and 3 hydrogen atoms attached to it are shown by shorter lines drawn at 120 degrees. Relative stability of conformations. In staggered conformation, electron clouds of carbon-hydrogen bonds are as far apart as possible. So there will be minimum repulsive forces, minimum energy, and hence maximum stability. So staggered conformation is most stable. When staggered form changes to eclipsed form, electron clouds of CH bonds come closer to each other. So this leads to increased repulsions. So the molecule will have to possess more energy and therefore it will be less stable. The repulsive interactions between the electron clouds which affects the stability of a conformation is called torsional strain. Staggered form has least torsional strain, whereas eclipsed form has maximum torsional strain. The energy difference between the two extreme forms is of the order of 12.5 kilojoules per mole, which is very small. Next, we shall learn about alkenes. Alkenes are unsaturated hydrocarbons in which carbon-carbon double bond is present. General formula is CnH2n. Alkenes are known as olefins, meaning oil forming. In alkenes, the carbon-carbon double bond is made up of 1 sigma bond and 1 pi bond. Carbon-carbon sigma bond is formed by sp2sp2 overlap, whereas the pi bond is formed by the sideways overlap of the 2p orbitals of the 2 carbon atoms. We know that double bond is shorter than single bond. The presence of weaker pi bond in alkenes makes them unstable molecules. So due to the presence of pi bond, alkenes are attacked by electrophilic reagents. Next we shall learn about nomenclature. Some of the members are ethene, propene, butene and so on. So first member is ethene, second member is propene, CH3CH double bond CH2. The next 4 carbon alkene is either but1-ene or but2-ene. 1-ene shows that double bond is present with the first carbon, and but2-ene shows that the double bond is with the second carbon atom. The next we have buta-1,3-diene, which is CH2 double bond CH single bond CH double bond CH2. Since 2 double bonds are present, it is known as diene. 4 carbon atoms are present, and hence buta, position of the double bonds mentioned, it is 1 and 2, 1 and 3. Therefore, the compound is buta-1,3-diene. Next, consider CH2 double bond CH3. The UPSC name of the compound is 2-methyl-prop-1-ene. Methyl group is attached to the second carbon and double bond is present with the first carbon. So the name of the compound is 2-methyl-prop-1-ene. Now consider the last compound given, CH2 double bond CH3. The UPSC name of the compound is 3-methyl-but1-ene. 4 carbon atoms are present in the longest chain. Methyl group is attached to the third carbon and double bond is present with the first carbon. Therefore, the UPSC name of the compound is written as 3-methyl-but1-ene.